Well, hello everyone. I am back again. Are you sick of me? Are you sick of me? All right. We have been trying to do this for basically, I don't know, 3-4 days, and we're finally here getting it done. All right. So we are going to talk about translating from an exponential function to a logarithmic function. And you're probably saying, well, Audrey, what's a log? So actually, a log is the inverse. Just like how addition is the inverse of subtraction and division is the inverse of multiplication and vice versa. The inverse of a square is a square root. The inverse of a cube root is a cube. The inverse of an exponential is your logarithmic. So you're going to be seeing a couple of different phrases or different things that you would normally see on your calculator, like your e's, okay, your exponentials, all those lovely things. So let's zoom in to where we kind of look a little bit at the formulas. So we're looking at the inverse of exponential functions. So we're looking at what's called a common log and what's called a natural log. So when you look at an exponent or an exponential, you have three things that's hitting you at once. So the first thing is you have your base. So if I'm looking at 10 raised to the second power, we get a result of 100. So my base is the 10. The 2 is my exponent. This whole thing, that 10 squared, that is your power. Not just the 2, the whole thing. 10 to the second power, that is your power. Keep forgetting I have to be like in the dark for you guys so you can see. All right, so with this, let's see if I can raise this up a bit. All right. So this is your exponential. All right. So this whole thing, 10 to the second power, this whole thing's a power, but this is your base, that's your exponent, and then you have your result. Whereas logs, little slide shuffle, it also has three things. Your base goes right next to the log, but your result is going to be next to your base, and it will equal your exponent. So the best way, what we're going to do is we're going to go back and forth. So we are going to look at what does it look like as an exponential, and what does it look like as a log. So we're going to kind of go back and forth. That's what we're doing. Hi, film artist. Hello, everyone. It's coming in. I appreciate it. Hey, pretty. All right. So the best way when you have a common log, okay, when you just see log, when you have a common log, it always gives you a base of 10. If you don't see anything there, this will give you a base of 10. All right, that's for all common logs unless there is something there. The best way that I used to describe it, it reminds me of football. So if I'm basically in the down position, I'm going to go past the defender and then I'm going to tackle up my, I don't know, say the quarterback, okay? So I used to say, okay, you're breaking through the defense, and when you hit, you don't hit straight on. If you notice in football, we never hit straight on. In rugby, they never hit straight on. They always hit down and low. All right? Now, because you don't want to break your neck and die, right? Gotta protect that. So when you're going from a log to an exponential, you have your base, it goes past the equal sign, that's your exponent, and it's going to equal the result that you left behind. When I look at an exponent, I have my base, and it's like going to reverse. You have your base, Then you have your results, and it's going to equal your exponent. So let me show you through examples. So we have 10 cubed equals 1,000. So if I want to write this is exponential. If I want to write that as a log, I'm going to have the word log. And the only time I know I'm going to use log as opposed to natural log is because I don't have that letter E involved. And you're going to see what I'm talking about later. So I write log. I put the base right down below. Since the base is 10, I don't have to write it because log comes naturally with a 10. Now, next to it, I'm going to write the result. The result is 1,000. So I write my 1,000. And then it's going to equal the exponent. And the exponent is a 3. So it's going to equal a 3. Okay? So you write the word log. You would write the base, which would be 10. So remember, the 10 is common, so you don't have to put the 10 there. You will put the result, which is my 1,000, and it's going to equal your exponent. Okay, let me try again. So now we have 3/4, 3 raised to the 4th power, equals 81. So we're going from an exponential to a log. So we write our log, then we write our base. Our base here is a 3. So I'm going to put a 3 as the subscript. Okay, it's a small 3. You're going to put the result. The result is 81 right next to it. And it's going to equal your exponent, which is a 4. All right. Okay. Thank you for stopping in, everyone. All right. So that's all it is. So why not give it a try? Okay, let's see what you guys got. Hey, avocado. So we have 6 squared equals 36. And I want you to write this as a log. What is natural log? We're going to get to that. So right now we're going to get to log. I know it's going to be kind of hard to write. So if you want to write it out in words, you can type it out in words. Or you can do that. Thanks, Monique. So we have log, I want to say base 6. The result of 36 equals 2. Okay, so we have our log. Okay, we have our base, which in this case is 6. The result, which is 36, equals your exponent, which is 2. All right. Okay, how are we doing? Okay. All of a sudden it got real quiet. Are you alive? Okay, this is so helpful. Good. All right, great. Good. All right. All right. So we're going to get into the natural log in a second, Hunter. All right. Okay. Now, we're going to flip it around. So we have the log base 2 of 8 equals 3. So now we're going to go from a logarithmic to an exponential. So we always start with the base. Base is 2. The exponent, so it always drives past the equal sign. So my exponent is going to be 3. Equals my result, which is be 8. All right. So give the next one a try. Log base 5, 25 equals 2. What would that be as an exponential? Hey, Dylan, I haven't seen you in a minute. Okay, when you're ready, go ahead and put it in the chat. Okay, oh good. Yeah, I think a lot of you guys are getting into logs. Because I've been having a couple people going into logs now. Good, I'm glad this is helpful. Okay. Any risk takers? What would I do? How would I go to exponential? Okay. And remember, question marks are always an answer or two that's accepted here. So if you're not sure what to do, go ahead and put a question mark as well. Because I know some people are coming in, some people are coming out. Or you're like, I'm not sure. And that's fine. So if you get it wrong, we'll just make the adjustments and then we'll keep it moving. All right? This is not Squid Games. You're not gonna die if you get a wrong answer. It's okay. Thank you for sharing the live, Evelyn. I appreciate it. All right. Okay. So your base is going to be 5. My base is down here. That's 5. So if I come across past the equal sign, that's going to be my exponent. So that's to the second. And it's going to equal the result that we're left behind, which is the 25. All right. Okay, that's all we're doing. So now for the next one, we have y equals 10 raised to the x. And you're like, whoa, okay, what happened to the numbers? So don't forget, you're still doing the same thing. My base is a 10. So if my base is a 10, that means I'm using log. And I don't have to write the 10 because a common log has a base of 10. It's not necessary. Now, what is the result? What is this equal to? There we go. Good job, gents. Okay, so it's equal to my result, which is y. Okay, so my base is 10, my result is y, and it's going to equal the exponent, which is x. So now, the part that everyone's been waiting for. This time we don't have a base. We don't have a base of 10. We have a base of e. So instead of drawing out the common log, we're going to do what's called the natural log, which is ln. ln has a base of e. And again, I don't have to write the e because it's always assumed to be there. Now, e is actually a number, guys. If you put in your calculator e and it just has you to put something, put to the first power. E to the first power, and you're actually going to see a number. So with this, we don't have to write the base of e, but I do have to write the result, which is y. And then I write the exponent, which is x. So y equals e raised to the x, and its inverse is the natural log of y equals x. Okay. And you're probably like, why are we doing this? Yes, you're correct, Hunter. Well, you should. You should. So let's do a little more practice with this, because then we're going to be working on some evaluation. So evaluating this. So while I set all this up, if you can do a little tippy tap tap, that would be amazing. Because there's what, 23 of us right now? Why is it instead of log? Okay. Eve was in here, Jojo. She did stop in here for a little bit. Okay. Since we have a different base, before we had numbers, then we had this letter E. So E is injection, not with a base, not a common base, but this is telling me it's a natural log. So instead of the E, we're using ln. Anytime you're dealing with an E, and you've probably seen this with, not exponential growth, with compound interest, you've probably seen it before when you were trying to find the compound interest that is growing continuously. Maybe you've seen this formula before. If not, it's coming. All right. So if something that is going to be compounded interest continuously, they always use the exponential. Okay. We're taking pre-calculus right now. Oh, okay. I think that's probably why she sent it to you, Jojo. Hey, love. How are you? Okay. Does that make sense, Monique? Okay. Good. All right. So, working on the log and exponential. So, let's kind of work a little bit more with transformation. So, let's say if I had, let's say the log of 15 to 225 is equal to 2. And I want to translate that to exponential. What would it look like if I tried to transfer log base 15 of 225 equals 2? What would that look like as an exponential? Oh, W. Baker, thanks for the follow. Appreciate it. Huh? Any takers? Any takers? Hey, Michael. Are you sick of me, Michael? Are you sick of me? I saw you sneaking in here. Like Michael has been to every live. I've been live 2 times today. Now I'm here for the official one. Okay. So what we're doing is we're moving from a log to an exponential. Okay. We have a base. My base, there we go. The base, we got our 15. Okay. Our exponent, I think it's a big number. Okay. My exponent is going to be to the second power. All we have to do is finish it. Okay, this is my first time learning this. Can we do another example after? Of course. All right, so my base is 15. My exponent, remember, blocking and pushing it up, that's my 2. Now we just have to write equals 225. So that's how you would go from a log to an exponential. Your base is always that superscript. Your exponent is always outside the equals, and what it equals, what the result is always next to. Algebra 2 honors. Yes. Hey, Seth. How you doing? Tomorrow. Okay. All right. So let's try another one. So if we go with log, if I go log p, let's do that. 3/2 is equal 3. Okay, we're going from a log to an exponential. I'm going to go sideways. Okay, what would this be as an exponent? Think about what we're doing. Okay, good. That's cool, Seth. Yeah, Ski, you're going to be good. All right, so think about what's happening. Think about, use this as a guide. So I have p to the 3rd equals 3/2. She's like, am I right? Did I do it wrong? Do I need to switch something up? I know, I just like to give that little moment of paranoia. All right. Anyone else want to try? Does everyone agree with love? Love Lola. Well, I do. Because your P is your base. Good. P is your base. The 3 is going to be your exponent. And it's going to equal your result, which is 3/2. Okay? So that's all we're doing. We're just moving from one thing to the next. But what happens if we got, all right, so that's example 1, example 2. Let's get with example 3. So what happens if I give you 17 squared is equal to 289? And I want you to put that as a log. Okay, good. No, we're not solving. All we're doing is just moving from exponential to log and vice versa. We're going to be doing some evaluating shortly. Okay, is this Algebra 2? Yes, it is. And this is when I know the end of the year is coming quick. Because once I start seeing logs, I'm like, oh, end of the year is almost here. Because soon enough, a lot of you guys are going to be doing state testing. Okay. Yeah, I failed. Aw. So this is like Algebra 2. So log is 17. 299 equals 2. Okay, tomorrow, 289 equals 2. Okay, I think I see what you're saying. So we got our log. I know it's hard to write it out. Base is going to be 17. Our result is 289. And it's going to equal my exponent, which is 2. All right. Well, all you can do is just try your best at it. You know, that's all it is. You guys got to remember, a test doesn't make who you are. It just kind of give you an idea of what you can do, what you can't do, and then you just learn from it and you move on. Learn from me. I used to be very high-strung as a kid. Now I'm just like, once I revealed or realized the truth, I'm like, all right, I could still work hard. But these tests, like no matter, you can go into it, like say ACCUPLACER. It'll put you in a class. Yeah, you might have to learn some things. Yeah, there's going to be a lot of stuff that you already know. You just go in, you do it, you get your grade, and you keep it moving. You know, no matter what, you're still going to have to show what your skill set is in whatever job you're about to go through. So, you know, it's okay. Breathe. It's not going to be the end of the world. Oh my God, I didn't do well on this test. Okay. The person that did the test doesn't know what your capabilities are. All right. So that's why it's like, try to do process elimination when it gets to those things, especially with multiple choice. When you get an answer, don't just sit there and celebrate. Hit the next question. Because the time that you gained from, you know, the questions that you know immediately, just answer it, keep it moving, and then you get that extra time to work on the problems that you want to sit down and process some more. Okay? You don't have to get 100 on that exam in order for you to be successful. Okay? All right. Getting off my soapbox now. All right. 8th grade. Should I know this? It depends on what you have. Is that Angie? Okay, it depends on what classes you've covered. Okay, because usually this is like an Algebra 2. Okay, good. Just learned this. Awesome, Lizzie. All right, so let's try one more. And then we're going to move on to evaluating. So if I had y to the negative 19th equals x, what would that be as a log? Okay, think of the process. Don't worry about the letters. Just think of the process. Hello, everyone. Welcome in. Think about what we did with number 3. I know it's hard to type it. I get that. Okay. Hey, Nicole. How are you? Okay, I'm going to walk it through you in a moment. Okay, so we have log y exponent x equals negative 19. We have log y. All right. So we're starting off. Since I don't have any e's, it's a common log. you always put the base as a subscript. So the base is y. So I write my y. The result will go next to it. So the result is what it actually equals. So it equals x. But then, to go from an exponential to a log, your log has to equal whatever your exponent is, which is negative 19. Okay. Trying to multitask? No. Oh, I know. Trust me, I understand. Okay. So, let me go back to the original. Okay. I can do that. So, for those that are just coming in, so you can have, well, maybe not zoom in that much. But if anything, take a picture of this. So going from exponential to logarithmic. So you have your base, will be your base here. The only time you don't have to write a base is when it's 10, because log has a common base of 10 already there. Then your result is what it equals. That's what comes here. Then it's going to equal your exponent. So your exponent now becomes the outsider. Okay. All right. Sure. I will do one more. Let's see. So, and then we can go into evaluating, which will carry over what we're just doing here. So if I have, let me do this one. So I have the log of 11 of 121 equals 2. Okay, so you see the log. I want you to put it as exponential. So we're going from logarithmic to exponential. This is like Algebra 2, William. Come and hang out, learn a little bit of math. So we're going from logs to exponentials. Likely to be on the SAT, on the ACT. Yeah, they always put at least one question. Okay, that's fine. How's it going with Calc 2? Hey, Sweet Nettie. Sweet Nettie 2. Okay, if you got the answer, go ahead and put it in the comments. If you're not sure, you can always have a question mark. If you think you have an answer, put the answer and then put a question mark at the end. Not for the faint of heart. Telling you, doing all kinds of fun stuff. What are you currently working on now in Calc 2? Yeah, Ski, can you put your, because you said, I think it's that. I think it's that. I don't see what that is. Sometimes my comments don't show up too well. Okay, so we got log 11 squared 2. Okay. I need this for tomorrow. But then again, it's basic log stuff. Okay. So P series. Oh, yeah. Ugh. Yeah, I'm not doing that, William. You're not lying. Yeah, that stuff keeps many people up at nights. Yeah, you are so right. It's definitely not the faint of heart. Okay. All right. So let's go with this. My base is 11. Okay, because when we go from log to exponential, we don't need the word log. So we have our base of 11, and that means after the equal sign will be my exponent, which is 2. So that's 11 squared equals my result, which is 121. Okay. Okay, how are we doing? Okay. Yay. All right. Okay. So now, what I'm about to do, I'm going to work a little bit like one step more. So that will be what's called evaluation. Right. Of course. So now we're going to do a little bit of solving, trying to figure out what's going to help us out. So while I set all this stuff up, go ahead, give a quick little tap. All right, so usually I try to come on at least once a day. Today, this is my third time because I wasn't here this weekend. You know, crazy stuff. But earlier, which I'm going to try to post, kind of looking at the inscribed circles. So sometimes I try to throw some geometry in here, you know, because sometimes those things show up on, like, say, GED, ACCUPLACERs, ASVAB, SAT, you know, ACT. So it's always nice to kind of have a notion if they do pop one of those questions up. So at least you can do process elimination. Okay. So we're going to do all this stuff. Hey, Alex. We're going to break things. I don't know how to do logs. Okay. That's fine. I'm going to walk you through it because you just got in here. So I was way off. That's all right. We're going to break it down. Right, exactly. Try not to go too far deep with it. So when we're evaluating or solving exponentials and logs, some of you guys, I forgot who mentioned that you were doing change of base. Let me take a quick skip. Someone said they're doing that now with Algebra 2. Who said that? Seth. There it is. Yeah, so Seth said they're doing change of base. So we can still do, if you want to, you could do change of base with this. Or we can kind of do a little bit of change of root. So meaning, if I want to go from a log and say I wanted to solve this, I can go from a log to an exponential. So if I do that, I have my base of 4. We don't see an equal sign, so we don't have like an exponent, so that's going to be my unknown. But all I know is 4 raised to some power is going to equal 32. So you want to think, 4 raised to what power will give me 32? I know that 4 times 4 will give me 16. So that's 4 to the second power. So 4 to the what power will give me 32? Yes. Not 4 to the 8. 4 times 8 will give me 32. But not to the 8th power. Because 4 to the 8th power is 4 times 4 times 4 times 4 times 4. Yeah, that's not. Okay. All right. So Leah says 2.5. I have 3. I have 3. It's 5 halves. No, it's not 5 halves. Eric's not 5 halves. Power over root. It's not 5 halves. Okay. 2 to the 4th. Yeah. 2.5. Not 2.5. Not 2. Not 1/3. Got 1/2. Okay. It's 2.5. All right. So let's think of our powers here. So let me do a little side note. So 4 to the first power. That's the same as saying 4. Okay. 4 to the second power. That's 4 times 4, which gives me 16. 4 to the third power. That's 4 times 4 times 4. So 16 times 4 is what? Yes. Okay, finally we got some people in here. All right. Because it's kind of like I was a little scared. Okay. Actually. Okay. That will give me that 64. All right. So now we got all kinds of fun answers here. So we know that it's got to be somewhere in between. But it's going to be hard for us to do it with a base of 4, right? So we're going to have to make some changes in order for it to fit. So we might have to change this 4 as well as this 32. Because if I just try to do 4 squared, 4 to the third, I'm not getting 32. So 32 is somewhere in here. Now, here's another thing. I know, Leah, you keep saying 2.5, 2.5. We really don't like to have decimals. Those are exponents. I know. Everyone's going to like that. So just leave it as your fractions, okay? So by changing all this, we can change this 4 to have a base of 2. 2 to the what power will give me 4? Okay. Okay, so we got a whole sea of 2's. Awesome. Now, we want to have the same base. So 2 to the what power will give me 32. There you go, Leah. Not to the 4th. Okay, the reason why we're changing is we need to have common bases. Because if you notice when I was trying to do, who asked us? Ashley. So notice when I was trying to do 4 to the first power, 4 to the second power, 4 to the third power, I wasn't getting 32. So it's going to be hard for me to break down with the base of 4 to get me 32, because 4 raised to any power doesn't give me an even number of 32. So I need to change the bases. So if I change this 4 to a 2, it's easier to do that because 2 squared will give me 4. If I need to change this 32 with a base of 2, I can look at 2 to the 5th. Because 2 times 2 times 2 times 2 times 2 will give me my 32. So now we have the same bases. Since we have the same bases, we can focus in on the exponents. So I have an exponent. We have 2x is equal to 5. Divide both sides by 2. You're going to have x is equal to 5x. Don't want to have a decimal, really. And the reason why I'm not like, oh, just do this over this, you know, try to get like the change of base, because I know I can do the change of base easily over here. I know I could do the power over the degree over root, but a lot of people don't know degree over root, okay? A lot of people don't know that. So instead of me jumping into something that they don't recognize, considering we were just going from log to exponential and exponential to log, that's too much of a huge leap. Okay? So remember, there's multiple ways of getting the same answer. Okay? Okay. Yeah, a lot of people don't like decimals. They'd rather have improper fractions. I don't know why. There's like a whole bunch of stuff going on in here. Are you a math teacher? I used to be in a classroom. 22 years. All right. To figure out x, more complex with x factor is unnecessary if you know your exponential rule. Yep, IDK, you hit that right on the head. If you know your exponential rule. A lot of people don't. Okay? Okay. How are you about to solve this? Okay. All right, drop it. I'm a junior, taking AP pre-calc. Good. It's not. Okay. We're just learning about exponential log rules we have to test on tomorrow. Okay, what about domains and logs? Can you show? Well, just still skip. As long since I've done math. Barely getting into logs and college algebra. I want to learn as much as I can. Okay, can you expand? Oh, why did you tell us I was wrong earlier? Because I'm tired, Eric. I've been doing this stuff all day. So I have my apologies. Okay. All right. Okay. So let's try another one. So if we have we got a log base 6, 1 over 36. All right. So log base 6 is 136. Okay. And we want to evaluate. Okay. All right. So bow tie says is a -2. Okay. Just do bases will cancel out. All right. So Leah, we got -1/2. Alex, yes, I agree. Okay. Just doing nonstop. I feel like I have been. And on top of tutoring all afternoon, monkey. All right. So now, if we go from a log to an exponential, good. We have a base of 6. We're looking for what the exponent is, and it's going to equal our result, which is 1 over 36. Okay. Right now, we don't have the same basis. But, like, I forgot who mentioned it. I don't think it was Alex. I think it was IDK. I think that's what it is. That mentioned that we really need to take a look at our exponential rules. Anytime we have a fraction, that's telling me, especially if I see this 36, that's telling me I got a negative number. Because remember, when we have a negative exponent, okay, our number drops into the denominator, or basically it flips. So in order for me to have a base of 6, I need to have a negative exponent. Okay, so I have the same basis of 6. When they have the same bases, I'll get my x equals -2. Because 6 squared is 36. In order for it to be a 1 over 36, I need to have a negative exponent. Because when we have a negative exponent, it basically drops to the denominator. So yes, Leah, I think it's Lee, yeah. You are right with the -2. Yep. We can change the base of the 36 to 6 raised to the -2. Yep, so we can have the same base. Yep, and some people are in college learning this. Yep. Okay, good. So sometimes it's like I recognize it with the exponent, okay? So I know, side note, I know that 6 to the first power is 6. 6 squared, that's the same as 6 times 6. That gives me 36. This had a 36 in there, but that 36 is in the denominator. So anytime I see like a fraction like this, like a 1 over a number that I know it could be squared with, that's telling me that I have a negative exponent. And I know that 6 to the second power would give me 36. So in order for it to drop down in the denominator and have it as a fraction, my exponent has to be a negative. And it will be a -2. Okay, good. In 11th grade, learning this AP pre-calc, good. I never did AP and don't do good with math, but in college I'm doing really good. Yes. Well, especially it's a different pace. Okay, it's a different pace. It's something I could have learned last year in algebra, wasn't on the curriculum. Everyone learns at different paces. Yeah, that's true. But that's okay. As long as we have that acknowledgement. Okay? So, trust me. No harm, no foul. Everything's good. Alright, so let's try. Let's see if we can try. Nothing too crazy, but crazy enough. So if I had the log base 2 of 1/4. Yeah, good. Okay. I got -2, I got -2, I got -2 again, -2. Okay. Square root 2 minus no. Okay. Yep. It's going to see if everyone recognizes it. Okay. So change it from a log to an exponential. So when we do that, we have our base of 2. We don't know our exponent, but our result is 1/4. So I notice that denominator is 2. I want to get a base of 2. So 2 to the first power is 2. 2 to the second power, that's 2 times 2. That gives me 4. So I can change this 1/4 to a base of 2. But it's not going to be 2 squared, because that makes that equal to a 4. We got a 1/4. So that means that exponent has to be negative. And since they both have the same base, now I can focus on just the exponents. So it'll be x equals -2. Okay. Not 6. Yeah, we don't have any 6s up here. Okay, good. All right. So let's try one more. Okay. What are we learning today? Evaluating and solving. Well, right now we're doing the evaluation piece. So if I have, let's see, this one. Okay, so we have our log base 49 1/7. Okay, so log base 49 1/7. No, I haven't done expanding or condensing yet. Today is like the first time. Insert it into your y equals. Okay. Yeah, because sometimes they want you to put the answers in interval notation. Yeah, you're probably going to need to look at it from your graphs to put it in your y equals. All right. Okay, think about. It's kind of like the first one that we did. Okay. So I got a -1/2, I got a -2, I got a -1/2, I got a -7. Hey Logan, how are you? Okay. So my sorry. TikTok just wanted to know if I'm still here. All right, so, okay. All right, so we have a base of 49. We're trying to figure out what the exponent is 49 to the what power that will give me 1/7? So right away, I'm seeing some 49 and 7. So I'm seeing some multiples of 7s happening. So why not change these two into having the same base? So when I look at this, that 49, let me change it to 7 to the what power? 7 to the what power will give me 49. Yeah, it's algebra 2. Okay, good. To the second, to the second, to the second. Yep. YouTube videos, if I get stuck, and go to 2 if needed. Okay, cool. Okay, so 7 squared. Okay, so that exponent of x is still there. Now, this 1/7, this also has a base of 7. 7 to the what power will give me 1/7. Think about what we did for the last two problems. Okay, so I'm seeing a 2. I'm seeing a -1. I think the 2 is from the last problem. -1, say -1/2. I don't know. Recommend. -1, -1, -1. Yes. So, because we got 7 raised to the -1st power. Anytime I'm seeing a fraction like this, we basically got the whole number down in the denominator. That means I got a negative exponent. So now that I have the same bases, I can focus on the exponents. So here, I'm going to have 2x is equal to -1. So when I solve, I'm going to divide 2 on both sides. So x will equal -1/2. Okay. Yeah, I agree. So here's one thing that I wish a lot of schools had, which is a calculator process. So like say, okay, after you graduate high school, you're still going to have to take a math class. There's no escaping it. So it's either going to be like pre-calculus if you haven't taken it as a high schooler, or some form of math for your major, right? So after you take those classes, once you get rid of that one math class, like you're done. So there was almost like there should be like a buyback. Like you can go to wherever high school you went to and you could sell your calculator. And maybe not the 100 because you know it's not going to be worth $100. But if you can keep going with this whole buyback, rental, not even a rental, it's like you have it and then you can go back to your high school and then sell it to someone else. It would be so much easier. Then everyone don't have to worry about Desmos because some teachers won't let you have a computer. There are some teachers, especially college, most of them are still doing paper and pencil because they've been teaching that way since you were a fetus. So they don't know about Desmos. You can do it for your homework, but then when it's time for you to take your exams, you won't be able to do it. Anything about AP stats? Taking it next year. I don't know much about it. I have a friend that does. Me, I don't teach it. Okay, what if there's no common base? What do you mean, Michael? Okay. What do you mean, Michael? There's no common base. Okay. I'm just waiting for Michael's question. Yep, it's easy, just like this. Okay, from problem 1. No, I'm not going to be covering domain tonight. Walls to pass A/B test. So you say from problem 1. I'm trying to understand, Michael. What happens if we don't have a common base? So like if there isn't like a 4, if there isn't a 6, and there's like a 2, are you talking about that? So like if I had just like log, I don't know, log 100, like what would that be? Okay. So if there's nothing there, it's always assumed that it's a 10. And if you want to, you could change that 100 to 10 to the second. So that means x is going to equal 2. Something like that. You okay, Michael? Or are you typing? You're probably typing. When there's no base for log, the base, yeah. No. No. Okay. Help me to understand. Yeah, because if you don't see anything, it's assumed that it's going to be a 10. Why is the answer negative? Because anytime you have a fraction, not every time, but majority of the time when there's a fraction as a result, that means you're dealing with a negative exponent. So you're going to have to double check with the rules of exponents or the properties of exponents when you have a negative. Okay. He means a weird decimal or a radical base. I'm going to cover in the next week. In the next week, yes. On Monday, and I need more practice. Okay. Yeah, so in the next week, condensing, expanding, using the properties, yes, I will. If not Thursday, definitely Friday. Okay. If you want me to support your music, all right, DM me. Let me say. As long as it's sweet and chill. I don't want to have like anything cry. Okay, I will wait until next week. Is that what you were trying to think of? I'm trying to figure out your question, Michael. I'm trying to see what that is. All right. If anything, definitely direct message me. Because it might be what I'm thinking of. It might be something crazier. All right. So, we were kind of dabbling, if I may. We were kind of dabbling on solving. Yeah, if you don't see, I think so. Okay. Yeah, I think that's what you're doing. Play around. So I got one person with an answer. So Eric. I do go live every day. And most of the time, and I think tomorrow I'll be here at this time, like 8:30, 9 o'clock. It also depends on my tutoring schedule. So sometimes I have people, I know definitely it's going to be like possibly 9 o'clock on Wednesday, because that's jam-packed, as well as it's going to be late on Thursday night as well. But sometimes I pop in during the afternoons. So if I have the time, I do it. All right, so I have 3 halves. Is the exponent positive? It can be. And then I have 3 halves. It's 3, and I have 3 halves. Okay. Love the battles. Okay, if you guys can tap, would be awesome. So I can start expanding all of this. So when I see this, I look at my base. This has a base of 5. This is 25. So I need for my bases to be exactly the same. So I always want to go with 5 raised to the what power will give me 25. So that's going to be 5 squared, because 5 times 5 gives me 25. Then I bring everything else down. So now that I have the same base, I basically ignore the bases. Now I can focus on my exponents. So I have 2n minus 1 is equal to 2. So I want to solve this for n. So now I'm going to add 1 to both sides. So now I have 2n is equal to 3. But then, don't forget, you have to divide both sides by 2. So n is actually going to equal to 3 halves. Okay? And if you ever want to check it, just plug in the 3 halves for your n. So that means 2 divided by 2s, they cancel out, gives me 3 minus 1, and 3 minus 1 is 2. So that will be 5 to the second power equals 25, and that is a true statement. This is just a check. Okay. You're so confused? Okay. Can I restate the... Yeah, I could. If I restate it, let me put it over here. So if I want to, it's going to be a log. My base is 5. My result is 25. And it equals 2n minus 1. So if you want, you could do change of base. Okay, so you can get the log of 25 over the log of 5, get that answer, and then you would add 1 on both sides and divide by 2. You can do it that way. Yeah, it's perfectly fine. So I'm kind of like getting a mixture of some people that will understand that and a lot of people that needs this. So it's almost like there's two worlds happening in one live. Can you do it with the calculator? Sure. I can do it with the graphing calc. So if you want to do it with the graphing calculator, you need to convert it in with a log. And you would do what's called a change of base, because it's best when your base is of 10, but these aren't of 10. So I take my log of 25 over my log of 5. So with the calculator, you have your log button, 25, divided by your log of 5. And that gives us an answer of 2. So that means when I have 2 is equal to 2n minus 1. Now I can solve this. Add 1 on both sides. So I got my 3 is equal to 2n. Then divide both sides by 2. And they'll give me my 3/2. Okay. But just plugging the whole thing in, you can do the calculator to get your log 25 over log of 5 to get your answer of 2. And then from here, you can just go ahead and solve. Okay. But putting the whole thing in the calculator, no. Well, you always want to equal. So in rainbows, when you're solving the equation, whatever you do to one side, you want to do to the other. It's like me. I'm a Libra. I'm a balancer, right? You got to balance things out. It's not like you're going to have like, I don't know. You never want to be uneven. You always want to even things out. So as you do on one side of the equation, you must do to the other side. Okay. All right. Let's try another one. So, just so I can separate everything over here. Okay. So let's say we have, I don't think I want to go that far. We'll go this way. I know it's basic, but I just want to make sure you understand the concepts. Okay, so we're working on this one right here. Okay, I want to work on this one right here. You like my shirt? Thank you, Amber. How are you? Oh, it is. It's definitely cozy. I had to break out the sweatshirts this morning. Or today, actually. Perfect. All right, so I'm getting some twos. 2 to the second power. How, Jonah? Base part. Something else. So it's almost like some solving. That's what we're kind of getting to. All right. Okay. How to do... Okay, got that part. All right. So we need to have the same base in order for us to tackle the exponents. So this has a base of 2. But this has a base of 4. This 4 can change into a base of 2. But it's 2 raised to the second power. So since we have that 2, we have 2n minus 2. So many 2's. All right? So now that we have the same base, we just converted that 4 to a 2 squared. Now that we have the same bases, we can really focus on the exponents. So that means I have 2n minus 2 equals 2. So we have a minus 2. So this is what comes back to you, Rainbow. We want to do the opposite. So we want to add 2 on both sides. Negative 2 plus 2 cancels out. Bring down my 2n equals 4. Divide both sides by 2. And our n is going to equal 2. Okay. How are we feeling? Okay. Are we overwhelmed? Are we like, we can do another one, I'm loving this? Or this is like, I feel like I'm about to lose my mind. So talk to me. Okay. My opinion. Okay, Mohammed. Nice. No where no common base. Okay. What do you mean by no common base? Is it because I'm not putting it as a log? Like, I really want to understand this. Right now, my brain is like, blah, blah, blah. I want Cheetos. Okay, this is fun. Good. Agreed. Awesome. Okay. Bridget. Oh. Messages are blocked. Ooh. Scandalous. Equals 3 instead of 4. Let's try this one. Okay. All right. How about so we have 6 x plus 8 equals 32. Ooh. How are you, Bridget? I'm like curious what you were trying to say, Michael. Getting things all. Ooh, The way I'm feeling right now, some crunchy Cheetos. But now I can't eat Cheetos because of the freaking dye that they put in it. It's so depressing. Like all my favorite little snacks and treats are just killing me quickly. That's the best way I can say. I'm okay. What if? Okay, what is it? Is 33 or not 32? 32. I'm stumped. Okay. Doritos as well. I know. Did you know those are flammable? Doritos? I don't want people like going in their house trying to set fire to themselves and stuff. But Doritos is highly flammable. If you run out of fire starter, just throw some Doritos. Boom. You get yourself a nice little campfire. Seriously. Try it next time you're at a campfire and then make sure you put it out completely. Getting tired of all these stupid wildfires and stuff. But I know it's not just because of that. Yeah. Oh, yeah. Highly flammable. You're like, I just ate a $7. Yeah. Oh, yeah. I'm not saying you're going to get full. Oh, no. Especially the servings at Taco Bell. It's ridiculous. You can just make your own and basically have the same, spend the same amount at the grocery store, make your own, and you'll still have tons left over. Okay. Yeah. Okay. Is the common base 2? Is it? That's a great question. Is the common base 2? Yeah, this one's a little tough. It's 6. I'm not sure what the common base is. Okay. It's all right. It is a little tricky. Ah. See what Pog said. Pog champion. Do change of base. Okay. We were kind of looking at change of base over here. Right in this little section right here. Don't ask me why the accent. I don't know. Okay. Because think about it, 6 squared, or 6 to the second power, that's not going to give you 32. That will give you 36. Do you log 6? You could log 6. So, when it's not so easy to break down, you might have to change it from an exponential to a log. Random accents. But there's times I have to remember I don't want to insult people. Sometimes I was brought up at a different time. It was a different time back then. Okay, 6 to the third power is 2 times 2 times 2. 6 to the third power is 6 times 6 times 6. Okay, thanks for the taps. I just want you to try to power it out first. I want you to try to power it out first. No pun intended. Just play around with it for a bit. Yeah, before I put my little 2 cents in there. Here, wait for me. Okay. It's okay. So we got log base 6 on both sides. Then change your base. Okay. So we got log of 32 over the log of 6. Okay. Okay. All right. Let's see if we can do a mad tap. If you're just like, okay, I'm ready. So I'm going to do a couple of... So if we can get close to... Yeah, if we can get close to like 9.2 likes, I would love that. And then I will show you. But I think a lot of you guys are right there. All right, perfect. That's lovely. All right. So I was hearing, or reading, not like I heard you guys talking through here. So one person was, well, we can't use 2 as my base because 2 to the second power gives me 4, 2 to the third power gives me 8. So there isn't anything with a base of 2 raised to a number to give me 6. For 32, yeah, because we did that. But then say, oh, okay, well, let me try 32. Well, 6 squared is 36, not 32. So we don't have anything right now that we can do to break this down. So what most people will do is they can either go from a exponential to a log. So remember, when you do your log, you have your base, which is 6, your result, which is 32, equal to your exponent, which is x plus 8. So it's not going to be easy for us to get a whole number out of this. So what we can do is a change of base, which has your log of 32 over your log of 6. And this is where the calculator is going to come in. But before I get into the calculations, I have x plus 8. If I want to solve for x, I need to get my x by itself. So I would subtract 8 on both sides. So we have the log of 32 over the log of 6 minus 8. So, handy dandy calculator. We have, oops, I'll get rid of that part. So let's see if I can slide it over and keep it in sight, in view. So we have the log of 32 divided by the log of 6. And we get this lovely decimal, 1.934264036. You know, the phone number that I usually give people so they can leave me alone. So now we're going to take that answer and we're going to subtract 8. So now we have this lovely answer. And let's see, most of the time, most teachers and instructors want you to round to 3 decimal places. Some would say 2, but I like to keep it to 3 because it kind of keeps it kosher. So we'll have -6 times 0, 6, and this is when I'm looking at that third spot. I want to round to that. So that means I need to look at the 7. If it's 5 and above, I'm going to give it a shove. That means I'm going to add 1 to that 5. So it'll be -6.066. Too many 6s. Maybe I shouldn't have done that. Maybe I should have just done it with 2 decimal places. Got a little scared. Okay. And I know, Leah, you had that answer up there for a minute. Okay. Okay. Hey, Kelly. You don't have. Hold on. Wait, I'm trying to get all the comments now. All right, so got that. Tap to 10K, guys. All right, thank you. When you don't have a common base, you log it. Yes. And I think, Michael, this is what you were talking about. Hold on. For when you can't find a common base. Yay! It only took 3 to 4 problems. So crazy. Here we are. We know to do this on Caltech. Why does my TI-83 only last 1 hour on a full charge? What? On a full charge? It's called batteries, man. Okay, I haven't seen you live in forever. You're still amazing doing this. All right, thanks, Kelly. Looks like my teacher says 4. Okay, 4 decimal places. Okay. Yeah, probably with the 666s, that's a little bit much. All right. Oh, they killed Kenny. Those bastards. Okay. South Park fan to the death. All right. Okay. Do I have energy for one more? Do I? Surprised Michael's not saying one more. Okay, finally answered his question. All right, so since I'm running out of space, I'm going to use this little piece of paper. This will be my last one. And then I have to go and do laundry and do adult stuff. Ugh. Adult stuff. All right, this is our last one for the evening. We got this. I feel like I've been pumping myself up. Did you just say 2 more? I was tapping. Okay, here's our 1 more. 1 more. Not 2. 1. Yes. There's 2 sides of that paper. I know there's 2 sides of that paper. I haven't seen you in a while, Bridget, and you want to cause trouble? No, I'm just kidding. No, I'm just really, really tired. Dude, I've been teaching or tutoring or encouraging and, since 10 this morning. So we're looking at 12, over 12 hours. That's crazy. Okay. All right. Moi? Causing trouble? Am I the drama? I'm not the drama. It's what I do best. Love it. Absolutely love it. This is why I go on live. Oh. Yeah, I got something different as well. Is that 10x? Yes, it is 10x. Hey, Cameron. Okay. Okay, we're going to check it in about 1 minute. Okay, so far we got a debate with 2 answers. We got 0.246 around there, or 247, and the other one is 0.247. 150 or 1.15048. Okay, somewhere around that. So how many decimal places? Let's go to 4. Why not? Let's be crazy. Let's just get wild. What was going on in your life, Audrey? It caused a commotion. I told them to round to 4 decimal places. Oh, hell broke loose. That's what I used to say to my students when there's like a discrepancy. And I'll just say as a side note, so Miss Codner, like, how did the fight start in your classroom? Well, one person said the slope was -2 and the other one said it was -1/2. Then all of a sudden there was blows. I don't know what happened. Everything just lost their minds and names are being called and all that stuff. Okay. All right, let's do it. So if I go from an exponential to a log, I'm going to have my log base 19. I'm going to have the result, which is 84. And it's going to equal my exponent, which is 10x. So when I come in with the handy-dandy calculator. All right, we'll try it this way. Something like this. Okay, so we have our log of 84 over our log of 19. So I got 1.504 and the rest is my phone number, right? Then we're going to take that answer and we're going to divide by 10. So it's like we're doing the log of 84 over the log of 19. It can't be the log of 84 divided by 19. Maybe that's what was happening. Hold on. No, that's not what was happening. I don't know what was going on. So I know if they're separated and it equals 10x. And then you have to, I know, a fraction with a fraction, it looks crazy. So even if you want to multiply by 1/10, you can do that as well. So the 10s will cancel out. So rounding it, I got my 0.150. Instead of a 4, it could be a 5 with my approximation sign. Okay, talk to me about questions. Okay, I am cooked. Yeah. You gonna test tomorrow? Okay. Where are we? How often do I go live? I try to go live like once. Today I went, this is my 3rd time. I'm on crack. No, just kidding. It was just too much of today. But tomorrow night I will be on, I think I'm going to be on at 8:30 tomorrow night because my last kid didn't show or wanted to cancel. So I'm able to come on early. Sometimes I'll be here at 9:30, but I think I'll be here at 8:30 till about roughly this time. You put a 6 instead of a 19. Okay. Got you. I'm trying to answer questions, but this thing keeps jumping. I never heard that in my life. They just gave us a bunch of formulas. Okay. Didn't hear what? Like wash. Okay. Show us how to do volume of 3D shapes. I think I actually did all the... Oh, no, I didn't. Share. Aw. Okay, cover natural logs next time. Yes, definitely. Yes, 8:30 Eastern Standard Time. Try to identify different shapes that you can break up and calculate volume individually. Yep. Awesome. Thank you for that. Sold today. I'm quitting sports betting. Yeah, that can get kind of crazy. How can I ever learn this stuff? Well, Kimberly, how long you've been here? This is my first time seeing you. Michael, one more, encore, encore. No. I gotta put my foot down. Okay. Ugh, guys. Just treacherous. Let's see. One more, please. We'd be forever in debt to you. Well, then keep tapping. Oops. I can't even type. I'm misspelling my name. Trying to log into something. I'm like misspelling my own name. Hello. That is cray cray. Let's see what we can do. Okay. Okay. Yeah, just like Bridget says, there's two sides to that paper. All right, let's try. Let me try this. Yeah. Nicole's like, what? Okay, a lot of it can be done with the calculator. But we need to isolate first. Okay. Yes. Okay, so we're going to subtract 4 on both sides. That is our first step. So now we're going to bring down our e, raised to the 3r. It's going to equal 59 minus 4, which gives me 55. Now, we need to do the inverse in order to get rid of this e. So this is when we are doing the natural log. Okay? So common log works well with just the whole numbers. But when you have an e, you have to take the natural log of both sides. Because what happens is this natural log has a base of e. So that means this base of e and this natural log, they cancel each other out. So it brings down the 3r. And then what happens over here, you're going to get your natural log of 55. So this is going to be a number that you can calculate in your calculator. But we want to get r by itself. So we need to divide both sides by 3. So now you have your r is equal to the natural log 55.3. But let me put my approximation because I know I'm definitely going to be rounding. And let's get it to 4 decimal places. So how I get to natural log on my calculator, I hit the second and the log button, or some people have log, natural log right here. Okay, so I'm going to type in my natural log of 55. Okay, hit my enter. And then I'm going to divide that by 3. Okay. All right. So if I round it to 4 decimal places, okay, I'll have 1.3358. So that's my approximation, 1.3358. Okay. Okay. So you're still isolating, even though, or although, it's in this form. Okay, we're still doing that. All right, now you got me addicted. So, okay. So if I have, this is gonna be my last one because right now I'm starting to see double. It's just not fun at all. Okay. Okay, last one. I gotta add these into okay. So you want to isolate your E. Hey, your mom. How are you? Austin. That's so many Austins. Patty. How are you, dear? I'm okay. Just doing our last problem, trying to wrap things up. Because I have to go into adulting. Okay. Ish. I love that. And do the ish. Gotcha. Okay. What grade is this? Well, this is like Algebra 2. Some people are doing Algebra 2. Some people have it in pre-calculus. Ooh, close. So not dividing the 6e, but dividing the 6 on both sides. Because we have to cancel out the e because the e is not a variable. It is a number. So we definitely have to isolate the e. Well, we're really trying to isolate the r, to be honest with you. There you go. Good. Okay. So to get rid of the e, we're not going to write log, but we're going to write the natural log. Because natural log and e will cancel out. So then you have your negative 10r is equal to the natural log of 63 over 6. Now, since this was supposed to represent a number, that's why we're not splitting it. We're not splitting it like how we did with the change of base, because it's not two separate bases. Okay? This is actually a number. So that's why we're going to put that all in one parenthesis. And then divide both sides by negative 10. Yep. And then this is when the handy dandy calculator comes in. So you got your natural log of 63 divided by 6. That's all going underneath the same parenthesis. Okay? So that's going all underneath the same parenthesis. Then divide by negative 10. Can you also represent the 1/10 as an exponent? Well, I know that it's a negative exponent. If it didn't have that r, I would suggest going like flipping it. So I would have flipped it. But since there's an r next to it, this is more so a solving, not so much like a simplifying or evaluating. But you are thinking, which is awesome. Okay. Yeah, if that r wasn't there, I would definitely do something with the exponent. But since that r is there and we're solving for that unknown, yeah, I wouldn't do it. Okay. All right. So first we want to get e by itself by dividing 6. But we're not trying to solve for e. We're trying to solve for r. So in order for me to get rid of this e, I had to take the natural log of both sides. Whatever you do on one side, you have to do on the other side. So now the natural log and the e cancels out on the left-hand side, which brings down my negative 10r. Now, you can keep this natural log of 63 over 6, because that's going to give you a lovely little decimal. So instead of you trying to simplify, you always want to simplify or round to the end. So that's why we're just going to divide both sides by negative 10 so we can isolate our r. And then what we get roughly, keep putting equal signs, approximately, okay, we got a negative 0.235, taken to the fourth decimal place, 1. So that will be what my r equals. Now I was saying for the natural log, No. Again, that R is still there, so you won't be able to do that. Okay, all right, I see you're okay. I got it right, but I put 10R instead of negative 10R. Okay. Not that, but the positive version. All right. Yes, just make sure you watch your signs, though, when you do transfer. But at least you see it. Okay. On the inside. Your mom, what do you mean on the inside? Join tomorrow. All right, cool. Have a great night. Thank you so much for the tapping. Oh, gosh. Thank you for being here. Okay. Bye. Oh, yeah, you don't want to have a negative outside the natural log, because then you're going to have to divide it afterwards. Nah, that's too much. I mean, you can, because you're going to get the same. Well, hold on before I say that. So, no, because if you do that, then that negative is really supposed to be with the exponent. And if you're putting the negative in front of the natural log, that's not changing the exponent. Because in order for you to change the exponent, you're going to have to flip your fraction. So yeah, I wouldn't do that. Okay. All right. Yeah, I would save the dealing with a negative exponent when you are evaluating. And that was, I'm just going to take this away for a second, or maybe longer than that. But when we were evaluating early on, like sometimes these things. So now if I wanted to get rid of my 1/7, I have 7 raised to the negative 1. These things the evaluations, I would deal with that negative. But when you're solving, no, I wouldn't do that. Okay? Okay, your mom. Okay, mom. All right. All right. So, everyone, I'm about to pass out. Okay, it's been a day. It's been a day. But did a lot of stuff. We evaluated and solved some exponents and some logs and a little bit of natural logs. We did some translating from exponential to logarithmic. All right. And on top of it, earlier, we just did a lot of stuff today. We did a little bit of measuring the central angles and arcs. I'm downloading those videos as we speak. That's going to be tomorrow. Then we had the inscribed triangles, and then sneak peek. Show a little leg. There we go. Inscribed quadrilaterals. That's going to be sometime tomorrow, maybe tomorrow evening. And I know I definitely want to add in some surface area. So if I do have time in the afternoon, we'll see. Oh, no, I won't. I have someone at 1 o'clock, so I won't be able to be in the afternoon. So I know this inscribed quadrilaterals, that's going to be like tomorrow night. And I know I'm definitely going to be doing surface area and volume of triangular prisms, rectangular prisms, because I have a lot of this. Man. And also surface area and volume of cylinders. So I definitely need to get some of that geometry in there so people will not be overwhelmed. If you like my book, okay, I designed this notebook. I did. It has 3 different covers, and I just like to have things nice and organized. If you are interested, I know it's close to the end of the school year, possibly keep it in mind for next year, or if you want to finish out the year. Definitely have 100 pages of notes. I usually draw a lot bigger because I'm doing this. I also have my factor sheet, which goes up from 1 to 200. Thinking about expanding that for my upcoming books. But it helps with factoring. It helps with breaking down square roots and radicals. All right, if you're not very strong with your multiplication, this really helps out. The rules of integers, also for some word problems. Then we have like linear and quadratic equations. Here are the properties of exponents. We were just talking and mentioning some of these, especially when we're dealing with the negative exponents. We did this today. Yeah, we did. All right. And then we also have the trig. So we have Pythagorean theorem. We have our sine, cosine, and tangent. For those that need a little help with volume and surface area, that's on there as well. And piece de la resistance for my older kids, the unit circle. So if you're interested in purchasing one, that's fine. I also put brain breaks in there because we all like a little brain break once in a while. Yeah, go ahead. You can get it on my website, which is in my bio. Just click on my picture. Go to my bio at ACG Math Tutoring. If you're just like, hey, Audrey, I'm really stuck and I really need tutoring. Hey, meet up with me. Go ahead, message me, or go ahead to my website, fill in the contact form, and we can take it from there. All right? So if there are any questions whatsoever, I will be here tomorrow night because I totally forgot. I do have someone at 1 o'clock, so won't be able to come in the afternoon, but I will be here tomorrow evening, probably at 8:30. And then we're going to take it from there. All right. Yep, I won't be in the afternoon until Thursday. Thursday will be the next time that I'll be able to do a 1 o'clock shindig. All right. All right. Okay, good. All right. Thank you so much, guys. I appreciate it. I appreciate the love. I appreciate the time and attention. Michael, it's always a pleasure. It's always a pleasure to have everyone. Yes, Tamika, it was so awesome working with you today. This is awesome. And if you have any questions, just reach out. And I think that's it. All right, I'm going to pass out. Oh, Melissa, where have you been? See you peeking in here. Lars, thank you so much for the follows, guys. Thank you so much for the love. And please remember, keep being awesome. The fact that you sat here and dealt with math with me on a Monday night. Hey, I am very proud of each and every one of you. I just want you guys to excel and to be big and to be brave and just keep being you. All right. Yeah, it's not a problem, Michael. It's always a pleasure. All right, everyone, have a lovely evening. And if you want to still be up and learn something new, my friend Lynette, she'll probably be on. She's probably on live right now as we're speaking. You can actually take a learning with Lynette. She does math through the abacus. So if you're ever really interested into the abacus, you can definitely take a look at her. All right. Thank you so much. I appreciate it. I'm super late. That's okay. I'm going to try my best to download the live. I know it's going to take a lot longer because this is definitely over 2 hours. It's going to be cray-cray. All right. So have a great night. And if anything, you can sign up for my, subscribe to my YouTube channel. That's where I put all the recordings of my lives on there. So if you want to go to that, that's under Audrey. Here we go. Type in one in. Let's check out that skill set. At Math Tutoring. Okay, that's not how you spell tutoring. Okay. Oh, those piano lessons that I took when I was a kid really worked. All right. So you can go to Audrey Codner, ACG Math Tutoring. I'm right there. I don't know why I did it multiple times. My God. Okay. Really did not mean to do it that many times. Weird. All right. So if you need me there, you can meet and get all the lives downloaded there. All right. Have a great night. Take care, Jonah. Take care, everyone. All right. Keep being awesome. Love you all. Bye.